Hello, Joy. How are you today? So, today we are going to talk about dispersion of light. So, what is dispersion? Do you know what is dispersion? Yes, dispersion is the breaking of a light into its constituent colors when light is incident on a medium. When there's a change in the refractive index, when we have two different medium, light breaks into its constituent colors. So why this happens? Uh, so we'll see today why this happens. How do we explain this? So do you have any insight into this? So I'll help you with that, okay? So 1 second, Joy. So what we learned so far, I can give you a hint. So we know that when there is a change in the medium, what happens to light? Yeah, it refracts. So we have a medium here, and so we say no normal, and we draw an incident light, and what happens? It bends towards the normal, provided that this is a theta 2, and here we have an angle of theta 1. So the light is bending towards the normal, right? And suppose we have n1 here, the refractive index, and this is n2. So we can say that what we have learned, what is Snell's law? Yeah, Snell's law states that n1 into sine of theta 1 equal to n2 sine theta 2, right? So n1 sine theta 1 equal to n2 sine theta 2. Now let's say, so does this help you to explain dispersion? So let me help you, Joy. So we have n1, and let's say n1 is air or a vacuum. In a vacuum or air, say let's take n1 equal to approximately equal to 1, and theta 1 as the incident angle, just say theta. So I can rewrite this as just sine theta, which is the incident angle, and n2, let's say n is the refractive index, n2 equal to n, the refractive index of the, say, glass. Here we have a prism, glass prism, and this is a refracted angle, n2 is r. So we have sine theta equal to n into sine theta r. Now I can rewrite that as sine of, are you following, Joy? Yeah, simple rearrangement of equations so that we can have a, right? So now, does this help you to explain what we are seeing here, the splitting of light? So let me help you, Joy. So we have sine theta, which is the incident angle, theta, and divided by upon n, right? N is the refractive index of the prism here, the glass prism. And theta 2 is basically, sorry, that is, this is r, which is, so sine theta of the refracted angle is sine theta by n upon n. So now, what happens? So theta, what about the incident angle theta for different colors? Yeah, it's a constant, it doesn't vary. All light is incident here at the same angle. So we don't have to worry about theta. So the refracted angle depends upon what? Yes, the refractive index of the prism or the glass. So now we have something, right? The R and N are inversely related, which means for some reason, if the refractive index of different colors are different, then we are going to get a different theta for different colors, right? So that is the case. So it happens that we can actually show that, say, for blue light, the refractive index of blue light, which is have higher frequency, is greater than that of red. So for red light, the refractive index is less, and for blue, the refractive index is higher, and this is in the visible region, all right? So what happens here then? So for blue light, the refractive index is higher, which means the refracted angle will be smaller compared to red. So how do we draw this here? So we are close now, right? It's very easy. So we have, I think we can draw a prism itself. That will be, so we draw the prism. Are you following, Joy? Yeah. Very good. So now I draw the incident light, say here, and this is the normal, and I can just extend the incident light here. And now for what will happen to, what will say the blue light will be, yeah, it will be close, its refracted angle, its refracted angle is smaller, right? So this is the blue light, and red will be have a higher angle. This is for red. This is the red light. So red light has higher angle of refraction compared to the blue light, which is smaller here. The angle is much smaller. So what we see here is that the blue light, this is the normal. The blue light bends more compared to red light, which has a smaller frequency. And all other colors from red to violet, depending upon their frequency, we find in between them. So what is dispersion? Yes, so depending upon the frequencies, the light components, the different colors has different refractive indices, and depending upon that, they are refracted at different angles. So we see the splitting of colors. We say the light is dispersed. Is this clear? Yeah, so it's very simple. This equation explains everything, right? You got it? Yeah, wonderful.